Yeah, so today we'll talk about a very new use case that we have been planning to test for quite some time, but finally this year in Berlin we found enough vendors supporting the new feature. You see the list of people participating. That's Arista, HP, Keysight, Nokia, and ZTE, who did take part of this testing in the frame of SR-MPLS testing in Berlin this year. So what's it about? You know about ISIS. You know that you can divide networks into L1 and L2 to separate a little bit the flooding domains. But that's probably not enough. It is much more scalable if you would be not limited to L1, L2 relationships. So that's when we received first implementations of ISIS instances. They reduce the IGP flood size, they allow your networks to grow, and growing networks is especially important when you come to the limits of the domain size. Especially with new technologies like SRv6, ISIS instances are very well implemented and desired, widely used, especially when you do the prefix summarization. In such a partition design, you would want to have some protection against wrong cabling. You want to have as well to do the TI-LFA, which is fast reroute across a shared trunks, across shared backbone links, similar like you do with the L1 and L2, but protecting more than just one single instance together. And what you definitely want to have is not to waste your time assigning IP addresses, VLANs on those shared links. So the example topology in real life would be some ABRs that are connected to multiple areas, different areas or levels of instances, name it as you want. And those would be metro rings, access rings in any form and shape. If you connect multiple of them to one pair of ABRs, you want this link or multiple links between the ABRs protect as a fast reroute to every such area. So we come now to the RFC 8202, which introduced multi-instances or multi-instance TLVs. The major point of that RFC is about Instance Identifier. So Instance Identifier is a part of every TLV, every announcement like a hello packet or sequence number or part of the LSPs. I have taken two captures from the same physical and logical link connecting two routers, and those two captures show you. So I have taken two screenshots of the messages exchanged by ISIS on the same link. On the left side you see instance 5, and on the right side you see instance 9. And we have even configured different parameters to every instance. You see instance 5 is protected by some authentication, while instance 9 has completely different set of parameters configured. So on the same physical and logical link with a single subnet, you have two or more instances running over that link. So what we actually did in Berlin, we provided a topology with ISIS instances. We configured, as usually, TI-LFA for segment routing over MPLS on the ABR link, and we demonstrated interoperability between the vendors. So we demonstrated single adjacency on one single link, and we have demonstrated as well multiple adjacencies on one single logical interface. In Berlin, we had a much more complex topology. For this demo in Paris, we brought only a few devices. Here, rows of ABRs are distributed between Nokia and HP boxes. So the link in the middle runs two instances. One is default instance, like backward compatibility to existing setup, and one is new, for example, a new metro area that you connect to your ABRs. On the right side is the green network. So we have two guys talking two instances simultaneously on one link. So these are the two south and north routers, and east and west routers are completely confined in their respective instances. So what we will do during the testing, we validate that adjacency is coming up, single instance or multi-instance. Then we will be sending traffic in VRF as usual. and that link is used as a primary link carrying the traffic. And at some point, some failure happens, and we expect and we want our ABRs to be protecting every single instance connected to them at the same time. So this is the purpose of this testing, and this is the enabler for your network growth for the foreseeable future. And now I will hand over to Matt to continue with the demo itself.
All right, thank you, Anton. So I'd like to show you a little bit about how this is configured and how it looks, just to show you how easy it is. So if you take a look, we have two instances configured on the box. One of them is the name domain 2, which is just a local name, configured with instance ID 2. And then we have another instance called IGP, which is not configured with an instance ID. Now the default is that if you configure just instance ID 2, we will put the TLV into the LSPs. Now, if you wanted to interoperate with an older implementation that did not support the TLV, you can turn off that particular TLV, but then of course you're not following this RFC. So let's take a look at what the database looks like. So just like Anton's output, you can see here we have the same field, right? Instance ID 2, supported ITID is 0. This is essentially what signifies that we're running instance ID 2 to the neighbor so that we don't get a mismatch. If we're running multiple instances on the same interface, we know which ones to join, which databases, and so forth. All right. Now, as he mentioned, one of the important things is that we need to maintain TI-LFA capability. So if we look at our TI-LFA path, so this is the path from the Arista node 142 to the HPE 287. You can see that we have TI-LFA available for our path to him, which you can then verify by looking at the route itself. Okay, and you can see this is the route to the prefix that is behind the Juniper box, and you can see we have it protected with TI-LFA here. In a bit, we'll do a test here where we actually physically break the link and show you the actual connectivity loss there. So if you remember looking at the traffic here, back up the topology here. So if you see the two Keysight ports on the diagram there, so we have traffic running between the two Keysight ports. So it's coming in from into Arista 142, leaving HPE 287 bidirectionally. And what we're going to do is we're going to actually break that link right there between the Arista and the HP box. And now it's going to have to back that traffic up over the dual instance link. So this is our Keysight statistics. And if you guys can see here, the important one to look at is the packet loss duration. You can see that we have 0 right now. The traffic is running. We have a frame rate of 1,000 PPS running bidirectionally. And what we'll do is go ahead and pull that link. Make sure I get the right one here. So we should see this update in a second. We should see some loss there. So there you go. You can see one direction we dropped 6 milliseconds, and the other direction we dropped 2 milliseconds. So now if we go back to our diagram, so this link here has now been dropped between the Arista and the HPE box, and now the traffic is coming back around and across that dual instance link. So.
Right, so that's the test that we have done as well in Berlin. We have repeated it multiple times for multiple instances to make sure that this trunk interface is protecting every of those instances. And again, this is the major enabler for topologies like link or metro regions connected in sometimes very weird fashion. It can be a chain of routers, it can be a snowflake or something else. But what people want to have is to provide core protection for those areas on the common link. And this is actually the enabler of the technology.
Yeah, and this would typically be used in a seamless boundary, right, where you have ASBRs. Maybe you're doing BGP-LU between the domains or something like that, and you have a shared link between the two. You know, the classic way, as Anton mentioned, would be you have to do some sub-interfaces with VLANs and so forth. But now you need additional addressing, you've got additional overhead because you have tags on there. And with this, you can essentially form multiple adjacencies on the same link, keeping them separate with the instance ID TLV.
Perfect. With this, we come to the conclusion, to the end of the demo.